Here we're asked to solve the system for x, y, and z. These problems can get a little bit lengthy, and there's so many different ways that we can do them that my method may look different than yours. So follow along if you want to use the same steps as me. You can also just check the answers and see a different way of doing it if you didn't do it how I did. So to start us off, I'm going to get a variable alone. I'm going to look through here and see which one is the easiest to deal with. I'm actually kind of drawn to this last one here because if I just add 2y to both sides, I get x equals 2y. So that's just my first step, is finding one of the variables that I can get by itself. So in this one here, x equals 2y. Now I'm going to use substitution, which is step 2, by taking this, because I know x is equal to 2y, I'm literally going to plug that into my other two equations. So the first one here, if I plug it in, looks like this. Then I'll multiply these together. So I'm just basically simplifying. If I need to distribute or anything like that, here would be the place for that. But I get simplifying to get y plus 3z equals 9. Now that I have done this, I have an equation here with just two variables, which is great. And now I am going to take this 2y, and I'm going to kind of repeat what I just did. I'm taking 2y here, and instead I'm plugging it into my first equation. So I'm plugging it into the two other equations, and it would look like this. So after simplifying, I now have two equations that I've created that just have two variables. Hopefully by this point, we know how to solve two variable systems by either using elimination or substitution. In this one here, when I look at these two equations, the red and the blue here, I don't see any quick and easy elimination, so I'm actually going to use substitution. I'm going to take this, it's going to get a little bit messy, so bear with me here, and solve for y, so that now I can plug this into y here. So that's going to look like this here. And now I need to distribute and simplify. And now that I have just z here, I can divide both sides by negative 29 and get z is equal to 3. So once I have z is equal to 3, I'm going to use that to plug it back into one of my old equations here. And I get y equals negative 3 times 3 plus 9. Y equals negative 9 plus 9, so y is equal to 0. So I have my second variable here. Now I'm taking y and plugging it back into my purple equation back up here, which gives me x equals 2 times 0. So x is also 0, and that tells me my final answer. So just to wrap it up here, I know that x is equal to 0, y is equal to 0, and z is equal to 3. If I wrote that as a coordinate, either of those two answers works for me, and we're all finished.